In one of my previous presentations, we used this rig to confirm that the exposed conductive part was connected to the CPC and therefore connected to earth. So we confirmed things like the metal light switches and the metallic light fittings had a connection to the CPC. We carried out continuity CPC and polarity. We left the circuit in the on position, and now we're almost ready to carry out insulation resistance testing. We need to remove all loads. There is no lamp in the bulkhead fitting, no lamp here, but at the moment I've still got the cover off on the fluorescent light fitting itself. We know for insulation resistance test all covers must be on. We also know that the earthing conductor in the tails needs to connect into the external earth source, which it is. So I've left the cover off on the fluorescent light fitting because not all loads are removed. We've got to look in there and see what part of the circuit is still connected, and that is also vulnerable for the test because it's going to be tested at 500 volts DC, and it will need to be removed before starting the insulation resistance test itself. So let's have a look inside that 2-foot fluorescent light fitting and see what's causing us all the issues. As we look inside our fluorescent light fitting, we can see the connections here for switching line, the circuit protective conductor and the neutral. However, on the back side of these connections, we've got the cables coming up into here, which is our electronic ballast. Therefore, when we pass our 500 volts through the circuit, we'll actually pass it through this bit of kit here. Obviously, we don't want to do that for a number of reasons. Obviously, it could damage the piece of equipment. Also, it will give us a false reading for insulation resistance. So we're going to need to either take out, and it doesn't matter which one we choose, the 2 conductors here for switching line, or the 2 in here for neutral, effectively then removing this part of the circuit here, so the electronic ballast becomes out of circuit. I'm going to put those into a connection before putting the cover on. Let's do that in the next stage. As I just said, it wouldn't matter which I took out, so I took out the 2 neutrals, I've put them in an inshore, Wago make the same style connector, maintenance-free connector. So now we've disconnected the electronic components from the fitting itself. Somebody out there is going to say to me, well, why didn't I take one of these white connecting leads out the back, which I can do. However, my students remove those several times, they're quite fragile, they break, and then I've got an issue of trying to replace this leg here. So I personally prefer, especially in my college, to remove the conductors in circuit and put them in this case, an inshore maintenance-free connector block. What I'm going to do now is obviously pop this back inside, I'm going to put the cover back on, and then we're going to carry out our insulation resistance tests with the electronic components within the fitting removed. So let's summarise where we're up to before carrying out the insulation resistance test. We did our continuity CPC and polarity, left the switches in the on position. We've removed all loads, no lamps are in circuit. However, we had an additional load in effect, which was the electronic ballast within our 2-foot fluorescent light fitting. In order to remove that, we could have taken out either the switching line or the neutrals within there. We decided to take out the 2 neutrals, we've put them in a maintenance-free inshore connector, and we've popped the cover back on the fluorescent light fitting itself. Our external earth source is connected. We're ready to carry out the insulation resistance test within the consumer's unit. We must remember, however, during this test that we have 2-way, in this case 2-way and intermediate switching. So we've got a 2-way switch, intermediate switch, and a 2-way switch controlling all 3 lights. So therefore we must remember the trick about throwing our 2 two-way switches in order to complete the insulation resistance test. Let's set up our Megger MFT and let's carry out that test. We've carried out insulation resistance tests many times on this channel, but however, we still need to check our instrument set up correctly. We're using the red and the green sections in the top of the instrument, and we need to confirm that our leads haven't broken or become damaged, so I like to short them together. So we're carrying out insulation resistance test, which is in the red scale for megohms. It's a 230 volt lighting circuit, so the test voltage is 500 volts DC. So rotate it around to 500 volts, and I'm going to short my leads together to prove that they have continuity. So we should get a dead short. And we've effectively got 000, which is a dead short. So our instrument's ready to carry out the insulation resistance test. So let's do that next. So let's recap then. The Megger MFT has been set to 500 volts in the scale for megohms, so we're carrying out an insulation resistance test. Our consumer unit is isolated, also the tails are isolated, they're not actually connected to the supply, but we do have to ensure for an insulation resistance test our earthing conductor is connected to the supply authority's earth. We've got no RCD protection in this circuit. We don't need any additional protection for an RCD because this is not a domestic dwelling, and our surface wiring system in plastic conduit and lights is one that we're suggesting is in a commercial or industrial environment. So no RCD protections, we haven't got any electronic devices from RCDs. However, main switch and circuit breaker off, doing the outgoing circuit, and we're going to test between line and neutral, neutral and our CPC and our line in any order that we like. So if I clip on first of all to the neutral bar, and then I'm going to clip onto the top of the circuit breaker, press and hold my tester. I've got a reading greater than 999 megohms. I'm now going to test between neutral and my earth bar, press and hold my tester. And now I'm going to test between the earth bar and neutral. And for the third time, I get a reading greater than 999 megohms. We know the smallest acceptable value of insulation resistance is 1 megohm or 1 million ohms. We know further investigation is required when it falls to a level of 2 megohms and below. Brand new installation, we expect the insulation material around the conductors to be in fantastic condition and have a very high reading, of which we achieved during the test. However, it isn't complete because in this installation we have two-way switching, in this case two-way and intermediate switching. So we have to walk back into the installation, throw both two-way switches into the opposite on position and return to the consumer unit. So let's do that next. So we carried out the insulation resistance test on the lighting circuit, however it isn't complete. Because we have two-way, and in this case two-way and intermediate switching, we must walk back into the installation and go to the two-way switches and throw them into the opposite on position, and then repeat the insulation resistance test. So we've got all parts of the circuit tested during insulation resistance. If we didn't, we would only have picked up part of the switching circuit, part of the strappers, on the first stage only, and we won't have completed that until we've thrown the two-way switches into the opposite on position. However, we can't walk away from a consumer's unit that is potentially live. In other words, the point at the top of the double pole switch, the tails may well be live. We couldn't walk away without returning the cover. So we must put the consumer unit cover back on if the consumer unit has any live parts in it. Our consumer unit doesn't. We have got the tails connected, but the supply authorities haven't connected the supply to the metering equipment at the moment. So we're okay to walk away from it, but just bear in mind as we move through our studies through level 1, level 2 and level 3 that at no point can you walk away from a consumer's unit that is live with the cover off. So we walk into the installation for ours, we go to the two-way switch, we turn it off, we go to the second two-way switch, we turn it back on, we walk back to the consumer's unit and repeat the insulation resistance test again, and therefore confirming that we've tested all parts of the lighting circuit for an insulation resistance test. And only at that stage can we record the results for that part of the circuit. Let's go back to the consumer's unit and do that. So we've gone out into the installation, we've thrown the two-way switches back into the opposite on position, meaning the other part of the strapper circuit is now in and requires insulation resistance testing. So we're back into consumer unit as before. We'll go between the neutral bar, top of the breaker first. Got a reading greater than 999 megohms. Between the CPC and line greater than 999 megohms, and then finally between the neutral bar and the earth bar. And we've got a reading greater than 999 megohms. We now can confirm that the insulation resistance test has been completed due to the fact that we have carried out the insulation resistance test in both on positions for the two-way switching. We've discussed it many times in other presentations, but it's still good to run over it again. So we've finished the insulation resistance test. We've ensured the electronic components in the 2-foot fluorescent light fitting were removed. The electronic ballast was disconnected when we removed the two neutrals in the first part of the presentation. We did the insulation resistance test twice. We did it on in the first position. We threw both two-way switches to get it on in a second position. So all parts of the circuit were insulation resistance tested. Before moving now on to another test, we must ensure, in this case, the two neutrals are reconnected in the fluorescent light fitting, and then we can move on. I hope this video has been some help.